As with any technology, machine learning can be used for good, for evil, or anywhere in between. There are a number of ethical concerns that can crop up unexpectedly even when you're trying to use machine learning for good. We're going to hear from Alex again about the limitations and ethical concerns with machine learning, but first, a personal anecdote. For Halloween of 2020, rather than dress up, I decided to create a voice-activated pumpkin. The idea was that as trick-or-treaters came up to my door, they would shout trick or treat. And I wanted the pumpkin to respond to this. Normally it would sit dormant and dark, but as soon as they said that magic phrase, it would light up and laugh, hopefully scaring them or at least providing them some level of entertainment. However, the problem with the project was that I had only collected data from an adult male and adult female for the phrase trick or treat. So when the kids came by and knocked on the door and said trick or treat, the pumpkin just sat there. The only way I could get them to trigger the pumpkin was to fake an adult voice. Try it as low as possible, and the kids would say it and the thing would trigger and they'd all laugh. But it missed it completely because I had inadvertently built in a bias in the model by leaving out samples from my target audience, and this can be really detrimental. This is a very benign example, but you can begin to see how this might prove very problematic for other things in machine learning. Now, let's hear from Alex about other limitations and ethical concerns you might run into.
Hello everyone, this is Alex, and now I would like to talk about one of the most important topics that relates to the field of machine learning and artificial intelligence, and that is ethical, responsible, and trustworthy AI and machine learning. So even though I, as a researcher in this space, constantly get surprised and thrilled by the rapid developments and breakthroughs, it is equally important to discuss the limitations and ethical aspects of machine learning and AI. So in a previous lecture, we talked about the 4 key enablers of artificial intelligence, and you can see them on the slide here. One thing that I want to point out is that all of these 4 factors also have a flip side or a downside associated with them. And in order to summarize that quickly, we can see that the huge amount of data that we have available today also leads to problems related to privacy issues and data integrity issues for individuals. So let's say that you're storing sensitive health data online somewhere in a database and that database gets hacked. Then your data will be lost forever, and it can be replicated by malicious actors as many times as they want. So data breaches and privacy violations are very common today, unfortunately, and we need to build more secure and robust systems that can handle these attacks. If we look at the computational power, then that has a downside of actually consuming a lot of energy and also being very capital intensive investments. If we look at the energy side of things, it is a fact that computers have become a lot more powerful in recent years, so you can do more computations on smaller chips. However, our demand for compute has also increased exponentially. So today we have data centers that consume a lot of energy, and because of that fact, they also emit a lot of carbon dioxide, and that is speeding up global warming. The third factor is algorithmic advancements. And it is a fact today that algorithms are getting better and better, but how do we know that they are actually getting better at the right things? So algorithms, they cannot show empathy, they cannot show compassion, and they cannot mitigate inequalities or reduce biases if we don't train them in specific ways so that they should mitigate these effects. One example is that neural network models and very complicated deep learning models, they are opaque in their nature, so they are almost like a black box. We cannot unpack this black box to see how decisions are being made. We only know that they have a high accuracy on the problems that they are being trained on. This is not good if, for example, we have an AI doctor that is giving us a result on an X-ray scan and tells us that we have some sort of disease. Then we might want to know how they came to that conclusion, but that can be very difficult to do for an AI system. Many of these new algorithms also introduce new kinds of biases into many processes that we have handled as humans before. For example, if we have an AI algorithm or a machine learning model that grants loans to individuals, then that credit scoring process could be handled by a machine learning model. And if that is trained on historical data that shows any kind of injustices between genders or minorities, then we would perpetuate those injustices with this new system, because every machine learning algorithm or AI model that is trained on historical data are going to pick up those historical injustices. The fourth factor, broad public interest, has the flip side that right now we have a lot of AI hype. People are hyping this technology and maybe over-promising what it can do and what it can deliver for us. Now, one way that we can look at trust in artificial intelligence is actually to compare that with how we humans trust one another. So just as we used the dichotomy between human intelligence and artificial intelligence when we defined AI, then now when we define trust in AI, we can use the dichotomy between trust in humans and trust in artificial intelligence. So some of the factors that allow us humans to trust one another are that we have developed morals and ethics, so we follow some sort of informal or formal rules. We might also have developed character, so we would say, oh, I would never hurt anyone else because that is not part of my personality. We also have societal laws that incentivizes people to be good to one another. We might also have cultural laws. They can be positive, sometimes they are negative, but these are at least things that allows us to trust in humans, because many times we will follow these cultural laws. We humans can also feel compassion, and that can be a source of trust. Now, if we look at trust in artificial intelligence and trust in technology, then I think this Venn diagram explains it very well. So in order for us to trust machine learning models and algorithms, we need to make sure that they are lawful, that they are obeying the law and policies. We also want this technology to be robust. We want the models to not be prone to attacks or that someone could take them down. Last but not least, we also want them to be ethical. So we don't want them to introduce biases or injustices into societies, or we don't want them to discriminate, but we want them to promote fairness and diversity. Another organization that has worked extensively on the topics of trustworthy, responsible, and ethical artificial intelligence is the European Commission. Here on the slide you can see the 7 key requirements for trustworthy AI as outlined by the European Commission in their report Ethics Guidelines for Trustworthy AI. The first aspect and factor is about human agency and oversight. So this means that we as humans should always have the final say and control over any type of autonomous agent or machine learning model that has been deployed. The second factor and requirement is technical robustness and safety. When we are deploying these systems in the real world and when they are making critical decisions for us, we need to make sure that they are robust against hacks and attacks. The third requirement is privacy and data governance. Data breaches can be very harmful both for companies and individuals, especially if you handle sensitive data like health records or financial transactions. The fourth requirement is transparency. Many AI algorithms today are like black boxes in the way that they make decisions. We need these models to be more interpretable and more auditable. Requirement number 5 is about diversity, fairness, and non-discrimination. We want these algorithms and models to increase the justice in societies and fairness overall. We don't want them to discriminate, we don't want them to be biased, and we don't want them to increase the inequality in societies today. Factor number 6 is about societal and environmental well-being. So we want these algorithms to combat climate change, to be good for nature, both when we're training them, when we're doing inference, and we also want societies to become better through the usage and the utilization of these new technologies. The last factor is about accountability. So it should be very clear what entity is accountable for the actions, decisions, and predictions that are being made by these machine learning models It should be clear if it's the developer at specific companies, or if it's the companies producing the products or the services, or if it's society that should set up the right laws and policies around usage of this technology, or if it's the user on the other hand. All of these are important areas where we need to work, questions that we need to answer, and scientific discoveries that we need to come up with in order for AI to work really well now when we integrate it into society. So with that, I want to say thank you for listening, and I look forward to seeing you in upcoming lectures.
Because of the potential to use AI for nefarious purposes, several companies have begun adopting end-user license agreements that define what you can and cannot use their products for. Ideally, we want to use machine learning for good and not to further discrimination or spread misinformation. A group of people at licenses.ai have created a number of responsible AI licenses that you can freely use in your projects. They outline the usual legal copyright and intellectual property clauses found in most end-user license agreements, but they also go into a number of restrictions on what you can and cannot do with the machine learning service. For example, you cannot discriminate along protected classes or use the service to create deepfakes without some kind of warning. Additionally, you cannot use the product to predict the likelihood that someone has or will have committed a crime, as that might lead to a Minority Report style pre-crime system. Edge Impulse has a similar license, but it has a few important differences. Namely, it prevents users from using Edge Impulse in ways that would harm animals, people, or society, as well as from uploading any personally identifiable information. I recommend reading through this license as well as the terms of service if you plan to use Edge Impulse in the development of your product or service. Alternatively, if you're building a machine learning system without Edge Impulse, I highly recommend familiarizing yourself with responsible AI usage in general prior to deploying it. AI is a powerful, budding technology, but like with any technology, we must act as good stewards to prevent its malicious use.